So in section 6.8, we talked about how to calculate an empirical formula. And now we're going to learn how to do a molecular formula once we know the empirical formula. Remember that the empirical formula is just the lowest ratio of atoms of each element. It doesn't indicate how many atoms are actually in a molecule. So the molecular formula tells us how many atoms are in a molecule, and that's always going to be some whole number multiple of the empirical formula. Sometimes that whole number is 1. Like for water, the empirical formula and the molecular formula happen to be the same. But other times it might be 2 or 3 or 7 or some other number. So when we have the empirical formula and we want the molecular formula, we have to figure out what that whole number is. So the molecular formula is going to be this empirical formula here. The example is CH2O times some number. And the way we find out what that number n is we take the molar mass, which you would have to be given. That's experimentally determined using like a mass spec or some other instrumentation, but nothing that you could know. So the molar mass would be given to you. Sometimes we'll give you the empirical formula. Sometimes we'll ask you to calculate the empirical formula from percent composition or something like that. You take the molar mass and divide it by the mass of the empirical formula. So here's the empirical formula, CH2O. You would calculate that, 1 carbon, 2 hydrogens, 1 oxygen, and find out how many times does that fit into the molar mass. It's like if you had a box of bowling balls that weighed 100 pounds, and each bowling ball weighed 10 pounds. How could you figure out how many bowling balls are in there? 100-pound box, each ball's 10 pounds.
Divide 100 by 10?
Yeah, take the mass of the whole box, 100 pounds, and divide by the mass of each ball, 10 pounds, and you find out there's 10 balls in there. So that's the same thing we're going to do here. Once you find n, then you're going to multiply all the subscripts by that. So let's do an example. So here we have a compound of phosphorus and oxygen, has a molar mass of 219.9 grams per mole. That's the mass of the molecular formula. They're giving us the empirical formula and saying, okay, what's the molecular formula? Well, we need to find out how many times this P2O3 fits into the actual formula. So we need to find the mass of that empirical formula. So we've got 2 times the mass of phosphorus, 30.97, plus 3 times the mass of oxygen. And I forgot to get my calculator up. Three times 16 plus 2 times 30.97. I did that backwards. 109.94. So 109.94 grams equals 1 mole of that empirical formula, P2O3. Now we're going to take that molar mass that they gave us, 219.9 grams per mole, and we're going to divide by the one we just calculated, 109.94. This is another of those problems where significant figures don't end up mattering in the end, so you could just use all of them. And that comes out, if we write out a bunch of digits, 2.00018, blah, blah, blah. So that's 2. So that means that there are 2 P2O3s in the box. So we know the mass of the box, that's the molecular mass, and we know the mass of the bowling balls, each one. That's the mass of the empirical formula. We divide them and find out that there's 2 bowling balls in the box. So there are 2 P2O3s in the molecule. So we multiply all those subscripts and we get P4O6, and that is the molecular formula. Any questions? I'll take that as a no, no questions. Clear as mud, right? So that's the end of the chapter. There's the chapter and review slides. You can read those yourselves. Chemical skills, that's what you should be able to do. Okay? Don't ask me if there's a study guide for the next test. That is your study guide right there.